So warm-ups cover up the answer. So if you're at home watching, try both of those and then come back and we'll look at them. So up the power by 1, divide by the new power, up the power by 1, divide by the new power. We good so far? Safe stop, yes or no? Not yet, like one step away. Plug in the 3. And then subtract, plug in the negative 1. So be careful with the, well, I say be careful with the negative 1. Like, safe stop now? Yeah, that's a safe stop. We're good there. The trick is on a multiple choice test, you can't stop there. You got to keep going. So let's see. 27 divided by 3 is 9. 9 minus 9 is 0. That's kind of nice. Minus, let's see, that would be negative 1/3 minus 1. Negative 1/3 minus 1 would be negative 4/3. But a negative out front would make that a positive 4/3. So, yeah, safe stop if you can, but on a multiple choice test, they're going to have you go sort of the rest of the way. Number 2, the opposite. So not an antiderivative, but a derivative. In fact, this would be a product rule. So f prime is 3e to the 3x. And g prime would be just 2x. So the order doesn't matter. One of them times the derivative of the other plus the other way around. And then we want to evaluate that at 2. So let's plug in 2. 2 times 2, e to the 6, plus 3 e to the 6 times 4 minus 1. Safe stop, but multiple choice test, 4e to the 6 plus 9e to the 6 equals 13e to the 6. Again, safe stop versus multiple choice. Oops, put that where you can read it somewhere. Now, take a moment and compare the two warm-ups to number 1 and number 2 on the multiple choice test. So 1 and 2, just like the 1 and 2 on the test. Speaking of algebra, I added, you may have noticed this if you've been in Schoology recently, I added a review assignment in Schoology. It's not due until Sunday, May 1st, so you have like 2 weeks to work on it, so it's not a big deal. I hope this doesn't show answers if I click on it, but algebra review, it's a matching. Oh, this
immediately showed answers.
Yes, about to show answers here. I think there's a show student view or something here. Oh, there we go. Well, preview question. We'll do it that way. There's only 4 questions, but each of the 4 questions has 3 or 4 or 5 like algebra questions in it, and it's rigged so that you don't get credit unless you get them all right. Now the trick is I set the attempts to the maximum number of attempts possible, which is 20. I hope it doesn't take you 20 to get them all right. But the point is I want you to do this until you get every one of them right. And when you do, then you'll have 100 as a daily grade. And so hopefully it's your first time through, but maybe you make a dumb mistake somewhere and then go back and fix it. I know that can be frustrating to go back and redo the thing, but I want you to get your algebra right. So this is an extra assignment I threw in. It shouldn't take too long, especially if you get them all right the first time. But it's just a bunch of algebra questions, mostly algebra 1. Like, this isn't hard. It's just you can't afford to, the calculus is hard enough on the AP test. You can't afford to be throwing points away on silly stuff. So that's it's called algebra review, I think. It's in Schoology. It's self-graded, 20 attempts. So That's added to your list of things to do, but it shouldn't take too long. All right, let's go over. Well, we won't do the first two because we just did the first two. The multiple choice questions. So one was B. One was exactly the number one on the warm-up. 2, I changed it up a little bit. 2 was D. Now you start telling me. I suspect we're going to do all of these, but maybe not. Number 3. Just somebody give me a nod if you want to see number 3. Okay. Let f be a differentiable function such that the point f of 2 equals 4, so that means the point 2, 4. The derivative, so that's slope, or dy dx. What is the approximation for f of 2.1 found by using the tangent line? Okay, well, tangent line means I need a point and a slope. So y minus 4 equals negative 1/2 x minus 4. So there's our tangent line, and we want to approximate f of 2.1. So that means we'll plug in. Whoops, I did that wrong. That should be x minus 2. So I'll plug in 2.1. So let's see, 2.1 minus 2 is 0.1. Half of that is negative 0.05. Plus 4 would be 3.95. Number 4, let g be the function. How many relative extrema? So that would be where g prime changes signs. Like so, number line, increasing, decreasing kind of thing. So g prime is 4x cubed plus 12x squared. Most of you did this much fine. You did this part fine. X plus 3. So we get x equals 0 and x equals negative 3. Most of you made it that far and said, aha, there are 2 relative extrema. But there are not. There are 2 critical points. So the long way around is to set up a number line and test different points. Do you know the shortcut on this to avoid testing the points? This x squared, what does that mean that x equals 0 is? Speaking of algebra. dr, what's dr stand for? Double root. What happens to signs at double roots? They don't change. So even without doing this, I know that there's not a sign change at a double root. There is at a single root. So I don't know if negative 3 is a max or a min without plugging things in, but it didn't ask me that. It just said relative extrema. So just x equals negative 3 because 0 was a double root. Yep. Because if that was x cubed, then it would be a triple root. And so if you graphed a triple root, you might remember that looks like x cubed as it goes through, but it does cross. So that would be a relative extrema if this was a triple root. So again, almost all of you got the calculus right. It's just that last little bit of making that algebra connection, or you stopped short of taking the last step. You saw that there were 2 critical points and just circled 2. Number 5, velocity of a particle moving along the x-axis. What is the average velocity? Okay, well, average velocity is change in position except that we don't have s of 3 minus s of 1. Maybe a different way to think of average velocity would be the integral of the velocity. because that we do have. And that it's the same thing as this, but we don't have a formula for position, but we could integrate the velocity. Just in the interest of time, I'm going to skip that or skip the rest of it and keep going. Number 6, I'm already thinking Riemann sum when I see a table like that, but who knows. On a certain day, the rate at which material is deposited at a recycling center is modeled by the function r. R is in tons per hour, T is the number of hours, using a trapezoidal sum with 3 subintervals. That makes sense, because we got 3 trapezoids. What is the approximate number of tons of material deposited in those 9 hours? So we need to add up. You need to sum up the rate times time with a trapezoid. So let's see, a trapezoid is the base times the average height base 5 times the average height plus the base 2 times the average height 5 plus 4 over 2. And this is no calculator, but they sort of made the math work out okay on this. Like the 2's cancel and you've got 24. And then 9 plus 5 is 14, divided by 2 is 7, times 5 is 35. Plus, on the last one, the 2's cancel, 5 plus 4 is 9. 24 and 35 would be 59, plus 9 is 68. Okay. So again, the algebra of, setting up the calculus right and then something going wrong in there.
Well, no, I wrote down 24 plus 35 plus 9, and then I put equals 70.
And then
Somehow I got 40 instead of 35. What the heck?
Let me answer Lauren's question. The x, or the independent variable, if we want to be fancy about it, is always the base. If you think about graphing this would be t, and this would be r. And so 15, 9, 5, 4. And so your base is that delta x or delta t. And your y value is the dependent variable, is the height. And unless they're really being tricky, the top one is always, knock on wood, always the independent variable. So the top one would always be the width of the rectangle, and the bottom ones would always be the heights. So you're always going to use these differences, 2, 5, 2, and then you'll always use these heights. Maybe not all of them, because if you're doing a right sum or a left sum, whatever. Seven was kind of tricky because, especially without a calculator, y1 was greater than y2 for part of the time, and y2 was greater than y1 for part of the time. So that was kind of annoying, because you probably would have had to set them equal to each other to figure out where they intersected. So let's see, so 6x squared plus 24x. Goodness, I can't math today. 6x squared minus 12x equals 0. Factor out the 6x. So like, they know if you don't have a calculator, when you have to do math, they make it kind of easy, or they make it work out. So x equals 0, don't really care about that one, but I do care about x equals 2 because I'm going from 1 to 3. So that means something's changing at 2. So I'll need two integrals from 1 to 2 of whichever one's on top from 1 to 2. Let's see, which one was it? Let's see, I think from 2 to 3, the x squared one would be bigger. So 6x squared minus 18x minus negative 6x. But from 1 to 2, it's the other way around. Negative 6x minus 6x squared minus 18x. That one's kind of tricky, because I suspect most people just did from 1 to 3 and got an answer. And my guess is if you just did 1 to 3, you probably get 4. So that one was kind of tricky. Number 8. The function g is defined by x squared plus bx, where b is a constant. If the line tangent to the graph of g at x equals negative 1 is parallel, what's parallel mean, algebra students? Same slope. So, and slope is derivative, to the line that contains these points, what's the value of b? Okay, well that means g prime is the slope is 4 minus negative 2 over 3 minus 0. 6 over 3 is 2. So the slope is 2 at x equals negative 1. G prime is 2x plus b. So that means 2 equals 2 times negative 1 plus b. So b equals 4. Again, the computations aren't hard, but there's a lot of words in there. Tangent line, parallel, points, find b, took a derivative, lots of stuff going on in that one. Number 9. I hope you remembered, actually I put this graph on the board now that I think about it. They really like this function in AP land. And you've just got to remember what it looks like. And they put this extra one so that there'd be a point there. And so the integral from negative 5 to 3, remember, integral means antiderivative, but it also means area. So this area is negative 5, and this area is 3. So negative 2. So that's supposed to be a quick and easy one if you remember what that graph looks like. So usually they ask like limit questions about this graph, but here they ask an integral about that graph. So that's sort of the only new parent function for calculus. So you've got to know that because they like asking questions about it. I think most people got G correct, or G, let G be a continuous function. Got number 10 correct because we've done enough of these that you knew to the 2 and the 1/2, and then don't forget to change the limits. So I could probably throw out the 2 and the 3 right away, and then the 1/2 on the front without working this whole problem. I think the answer is D. But most people got that one. 11 was tricky. So find the integral, but that means area, so everybody got that much. And most people even figured out, okay, so it's the rectangle minus the half circle is that area. So the rectangle is 10 by 6, and the half circle is, let's see, what was that radius? Radius was 5, so pi times 5 squared. And so quite a few people picked 60 minus 25 pi over 2, which is answer choice B. But that's not right. Because, why is that not right, do you know? It's under the graph, so it's negative. So that one was a tricky one. So it's not, well, that area is equal to this. That's true. But the integral is the negative of all that. So it's answer choice C. In fact, there's my first pass at that problem. Found the area, circled B, and then thought, wait a minute, that's not right. Something weird is going on. It's under. So I changed it to C. Almost got me. A lot of you got 12. Acceleration is 6t, and it wants to know about position. So I need to back up, like take underderivatives here. Take an antiderivative to get to velocity. But it gives me, at time 0, velocity is 10. So C is 10. And back up once more. And again, they've sort of rigged it to work out to give you nice numbers. Initial position is 7. And then S of 2, 8 plus 20 plus 7 is 35. Kind of breezed through that one, but a lot of you did well on that one. 13 is kind of a pain just because it asks for a third derivative, so you just got to be careful. First derivative of cosine would be negative sine, and then minus 1 over 2x times 2, chain rule. So a few people forgot the chain rule, and that messed you up the rest of the way. Negative sine x minus, I'm just going to write this as x to the negative 1. Second derivative, negative cosine x plus x to the negative 2. And then third derivative would be sine x minus 2x to the negative 3. So that would be A. A lot of you put C, which so somehow you lost that 2 in there. Uh, 14, skip 14. It's a hard one. I don't want to spend the time on it. We're kind of pressed for time. So 15. Let f be the function defined above, where c is a constant. If f is continuous at x equals 1, what is the value of c? So that means the A branch has to equal the B branch at x equals 1. So 6 plus c times 1 equals 9 plus 2 natural log of 1. What's the natural log of 1? Algebra experts. Natural log of 1 is 0. So 6 plus c equals 9. C equals 3. That's another one where the calculus is easy, but did you get the algebra part right? Slope field. This was disappointing. I don't know how else to say it. The number of people that missed this one. I thought slope field wouldn't be too bad. Let's see. It depends on x and y. So that means, I don't know. I think that means I can throw out b. B looks like it doesn't change with y. So I threw out b first. The others are all kind of crazy looking, but so I couldn't throw any of them out. What did I think next? I think I started saying, well, if x equals 0, then If y is 0, y prime is 0. If y is 1, the slope is 1. If y is 2, the slope is 2. So I start looking at when x is 0 to see if those fit. That one does. This one doesn't. So I can throw out c, because if y is negative 1, the slope is negative 1, and that didn't happen, so I threw out c. For d, that looks okay. So I'm down to b and d. And what did I pick next? I think I looked for something that had a different slope. So like right here at -1, somewhere in there, these clearly have different answers. So at -1, -1, the slope should be 0, and it is for D, but not for A. So that was maybe a tricky one because that's a weird slope field, but you just plug in points until you rule them all out. It's basically how to do it. 17, I remember specifically that some people didn't like. Since we're recording, I won't call out names. I'll just look at the person who complained that they hadn't seen one like that. Which of the following works for this equation? And yeah, I don't know that we've done something quite like that, but let's find a derivative and a second derivative and see if we can figure this out. 3e to the 3x minus 5 would be the first derivative, and the second derivative would be 9e to the 3x. And basically we just need to see which one of those works. So they all start with 9e to the 3x, so that part's the same for all of them. And then they all subtract some number of y primes. And then they add or subtract 15. Well, if I want the e to the 3x's to go away, I need a 3 right there to make the e to the 3x's go away. So I can throw out c and d. And then I've got, let's see, minus 9e to the 3x plus 15. So if I want it to equal 0, I need that minus 15 on the end. So it's answer choice A. Yeah, have we done one like that before? No. But it's a bit of a plug them in and see which one works.
Why did you subtract it? Like, where did that... So you found the derivative and the second derivative,
and then I'm trying to shortcut it, but basically I'm plugging first and second derivative into all of these and see which one works.
Zero?
Which one gives me 0 at the end. And this distributing the minus sign to make this plus differentiated between the plus 15 and the minus 15. And so yet another problem where you could get all of the calculus right and not distribute a minus sign and miss it. Frustrating. 18. F prime, so of inverse sine. F prime of inverse sine, that would be 1 over square root of 1 minus x squared. So that one's pretty straightforward. It's just, do you remember the derivative of inverse sine? And even if you do, are you okay? Right? Safe stop. Hey, great. Except that didn't look like any of my answers. Although, I could throw out the pi stuff. So that would be if someone was just doing sines and cosines. So at the very least, I'm guessing between C and D. Let's see. So 3/4. 1 minus 3/4 is 1/4. The square root of 1/4 is 1/2. 1 over 1/2 is 2. A little bit of calculus, a little bit of algebra. guess there's a common theme here. The calculus can rule out a couple of the answers, and then algebra gets you the rest of the way. Nineteen is one of those that's supposed to be, if you recognize what's going on, it doesn't take long. If you try to actually plug in and find the limit, it's going to be ugly. You know what? Did anybody get this one right? And if so, how did you do it? Because there's two ways to work this one. Emma, what'd you do?
Well, I got the 0 over 0 thing.
Yeah.
And then
What'd you do after that?
I think I separated it.
Did you L'Hopital it?
No.
Okay. So the two options are you get 0 over 0, and so that should trigger in your brain, wait a minute, that means this is L'Hopital eligible. So derivative of the top, 20x to the 19 minus 3. And then what about the derivative of all this stuff? E to the 20th and 3e. That's all just numbers. So that goes away. And then in the bottom, the derivative of x would just be 1. Derivative of e is 0. And then so if we plug in e, thank you, L'Hopital, we have an easy question. That's not how I did it the first time. Do you care how I did it the first time? Sometimes they can specifically test. I thought this looked like something like f of x minus f of a over x minus a, which means it's the derivative at a. You recognize that they're giving you the definition of a derivative of this guy. But that's the same thing as L'Hopital. So if you take the derivative of that guy, you get that. So either way, you end up taking a derivative. L'Hopital probably would have been the better way to go. Let's see. This one's not too bad, especially after what we did yesterday. What's the derivative of y cubed? What's the derivative of y cubed? 3y squared is part of the answer, but dy dx is the rest of the answer. And so my bet is that extra part there makes the difference between the right answer and the wrong answer.
Wait, could you please do that one, like all the way?
Yeah. So 3, you're good up to here.
Yeah.
So the y is 2. dy dx, well, I have an expression for dy dx. It's y cubed plus 3. So 2 cubed plus 3. So 3 times 4 times 11. So that's not the easiest, but 12 times 11, and even if you don't remember your times tables perfectly, you look at your answer choices, and then maybe you're like, oh yeah, I remember back in 3rd grade, 12 times 11 is 132, because it's not any of the others. Chain rule, h prime is f prime of g of x times g prime of x. Again, chain rule. In fact, that's kind of interesting. I just noticed that 20 and 21 are both chain rule type questions at the end. I mean, they're very different. One's equation, one's table, but it's basically, do you remember the chain rule? 22 is similar to what we're doing now. Separate variables. Integrate both sides. Y squared over 2 equals x squared over 2 plus x plus c. I would multiply through by 2 and then square root both sides. Although when we put the square roots on, we got to have a plus or minus. And So we're already down to C and D. And if the answer, if we plug in 0, we get -2, well, the only way that's going to happen is with answer choice C. So I didn't really work this the full, correct, formal way. I used my answer choices to skip around a little bit. #23. Frustrating because many of you put answer choice D. So like you recognize that there's two things going on here. From 1 to 2, if I rotate it around, that's a disk. So I need 1 to 2 is disk, and 2 to 4 is washer. And so most of you caught that. And so you were down to C and D because you got a disk and a washer. The disks are the same, so that must be right. And then a washer is R squared minus R squared. So answer choice D is R minus R squared. Answer choice C is R squared minus R squared. So it was C. But a lot of you picked D, which was like great that you recognized you needed 2 integrals to get everything, to get both pieces, but you missed the R squared stuff. 24 looks like a L'Hopital problem even before I start working it. If I plug in 3, I get 0. Derivative of tangent is secant squared. Let's see. The derivative of e to the x minus 3 is e to the x minus 3 minus 1. And if you plug in 3 for that, you end up with 1/2. That's super quick, but so a little bit of L'Hopital, a little trig rule, and then some substitution. And the bell's about to ring. There it is. I guess just keep the test, and I'll take them up tomorrow, because those aren't supposed to